let's figure out how to find a line of linear regression using our graphing calculator. This is also called a best fit line. So the first thing I'd like to talk about is just the scatter plot. So the scatter plot that I've created down here is using the information given above, each year starting with year 0 or 1900 going to 1980, and the value for life expectancy. So what we would be doing with a linear regression is trying to find a line that would best fit this data, even though our data points don't actually go in a straight line. So what we're trying to do is fit a line to this data so we can predict something that's going to happen out in the future. And we're going to do this today using our graphing calculator. So before we get started with any of the numbers above, we need to make sure our diagnostics are on. So if you'll go to Second and Calculate, down here on the bottom above the 0 is Catalog. You're going to want to go all the way down in your calculator, so keep going down. They go in alphabetical order. And we're looking for something that says Diagnostics on. So hit Enter and Enter again. And this just ensures that we have everything we need before we get started on this problem. So let's get out of here. I'm going to clear this off my screen. My diagnostics are on. And I'm going to go and I'm going to put this information into a table in my calculator. So above the word stat, you see list. Just hit the stat button, and it says edit. And we're going to be editing the list in our calculator. So hit enter, and I have things in my list. So I'm going to go over and use my up arrow key, go to list 1, and I'm going to hit clear, and then the down arrow key. And then I'm going to go to L2, use the up arrow key, hit clear, and use the down arrow key, and that will clear out my list. Now, in list number 1, we're going to be putting the years. And they ask us in this question to go ahead and let years be 0, 2, 4, 6, and 8. So that's what I'm going to do in my calculator as well. In list number 1, I'm going to type in those values for year, 0, 2, 4, 6, and 8. And I'm just entering the number and then hitting the enter button after each one. Use the over arrow key, and then we're going to put those values for life expectancy in the second list. So 4.79, hit enter, 50.2, enter, 51.8, enter, 53, enter, and 54. And one of the things to check for, just a real quick check, make sure you have the same number of entries in list 1 as you do in list 2. Now, in your calculator, hit that stat button again, and one of the things that has on there is the option to calculate. Go over to calculate, and then right there, option number 4 is linear regression. It says AX plus B, that's MX plus B for most of us. Excuse me, we have to type in which list we want to use. So notice above the 1, 2, and 3 buttons down here, we have L1, L2, and L3. We use list L1, so second and the 1 button will get us to list 1. You need to put a comma in between your list names. So there's the comma right above the 7. And then list 2, we're going to do second and the 2 button to get to list 2. And now hit enter. So in your calculator, this thing says y equals AX plus B. This is the same thing as MX plus B. But then they go ahead and tell you that A is equal to 0.75 and that B is equal to 48.38. So what we'll do next is go ahead and put this into our equation. So there's our A and there's our B. So we have y equals 0.75x plus 48.38. This is the equation for the line that best fits our data given above. So if we look at our options, A A has a slope of 0.75, and B has a slope of 0.75. D has a slope of 48.38. That's not supposed to be the number in front of x. This doesn't have an x, so those two are out. And then we're looking for a B value of positive 48.38, because all of our life expectancies are actually growing, so our B value should be positive as well. So there is our line for regression. There's our value. So the reason we had to do the diagnostics on is so we could get this thing down here, these r and r squared. The coefficient of correlation is this value for r. So 0.985 if we round to 3 decimal places. And what this coefficient of correlation tells us is how well our line actually fits our data. So if you thought about this as a percentage, this is really that it connects our data 98.5%. 100% accurate would be ideal, but this says it's 98.5% accurate. So we have a little bit of error, but not too much. The closer we are to 1, a value of 1, the better fit our line is. So is the regression line a good fit? Absolutely. It predicts our value 98.5% of the time. Finally, the life expectancy in the year 2020. So what they want us to do is continue this table, and we're looking for the year 2020. What is the value? So remember, this is going by 2s, and that is for every 20 years, it's going by 2. So we used 0 for 1900, 2 for 1920, 4 for 1940, and so on. So what x value would 2020 be represented by? So we have 1980, and 20 more years would have an x value of 2000, which would also be represented by 10. And then 2020 would be 20 more years, so that will have an x value of 12. So let me write that down. A 10 would be the year 2000, and then we have 20 more years added on to that, and that is an x value of 12. So the life expectancy in the year 2020, go ahead and plug 12 into that equation you just found. And I'm going to use my calculator. Clear to get out of all of that. 0.75 times 12 plus 48.38 tells me that the life expectancy in 2020 is 57.38. It tells us to round to 1 decimal place, so 57.4 years.